right, ladies and gentlemen, we're going to take a look at solving these equations, and they're specifically quadratic equations by factoring. And what we have is the zero product property. And what the zero product property states is that if you have a factor A times a factor B, and it doesn't matter whether A is a rational number, an integer, it doesn't matter if it's a variable, it doesn't matter if it's a binomial, like we've been multiplying together. If A times B is equal to 0, then A equals 0 or B is equal to 0. And as you know, guys, that's the only way to get 0 in multiplication is if one of your two factors is 0. So then how are we going to use that? Well, we're going to take these quadratics that we've been factoring and put them into an equation form. We are going to set them equal to 0. So what we have here is we have A times B. So if I have A times B is equal to 0, then I know either that A is equal to 0, so x minus 3 is equal to 0, or 2x plus 1 equals 0. And because these are quadratics, what we're going to find is there's now two solutions. That's what happens when we move from linear to quadratic. The number of solutions is going to increase. So to solve this, we simply undo subtraction by adding 3 to each side, either by showing that or doing our mental math. And we get x is equal to 3, or we can solve here. Subtract 1 from each side. 2x is equal to negative 1, and then divide by 2, and so we get x is equal to negative 1/2. So these are our two solutions. And so what that means is if I plug 3 in for x, I get 3 minus 3 times 2 times 3 plus 1. This is 0 times 7, and 0 times 7 does equal 0, so it works. If I plug negative 1/2 in, I get negative 1/2 minus 3 times 2 times negative 1/2 plus 1. Negative 1/2 minus 3 is negative 3 and 1/2 times negative 1 plus 1 is 0. And so negative 3/2 times 0 is 0. So what we find is whether I plug 3 in or whether I plug negative 1/2 in, they're both going to give me 0. So let's take a look at what happens when they're not in factored form. Well, when they're not in factored form, that's our goal, is to factor. X squared is x times x. Negative 38 is a positive and a negative. And so I have 1 and 38, 2 and 19, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6, 7, 8. I believe that's it. I believe we just have the 2 and 19. So how am I going to get negative 17 here? Positive 2 and negative 19. Now that's factoring. I have to solve. So I have to take x plus 2 is equal to 0, or x minus 19 is equal to 0. Subtract 2 from each side, you get x equals negative 2, or add 19 to each side, we get x is equal to 19. If we take a look at this next example, we still have to factor. I've got 1 and 14, 2 and 7, 1 and 9, or 3 and 3. I'm going to start off with the 2x and 7x. Positive 9 with a positive b value is plus plus. Now when I'm looking at this, I need to get close to 27. Well, I know 3 times 7 is going to give me 21x. So I'm going to try that, and I'm going to try the other 3. And I'll get 6x. So what that gives me is the 27x that I need. So what I need to do now is remember that these are set equal to 0. So I need to take 2x plus 3 and set it equal to 0, and 7x plus 3 is set equal to 0. You're still going to subtract 3 from each side. So we get these two statements, 2x equals negative 3 and 7x equals negative 3. But if I divide by 2, I get x is x equal to negative 3/2. I then have to divide by 7, and I get x is equal to negative 3/7. It's okay not to have nice integer solutions. All right, so we took a look at this, but sometimes we do have to end up with our fractions for our solutions, and that's okay. So let's take a look at our last example. Now we're taking a look at solving when it's not in standard form, which means we don't have our zero product property. In order to use the zero product property, the quadratic needs to equal 0, which is what it means to be in standard form. We have to have ax squared plus bx plus c equals 0. So let's do that. Let's figure out where we want to put 0. Well, on this left-hand side, I've got 3x squared, I've got minus 11x, and I've got minus 15. But on the right-hand side, all I have is 2x and minus 5. And so what I'm going to do is I'm going to move these over here. I'm going to get this right-hand side zeroed out. So I'm going to subtract 2x from the like terms, and then I'm going to add 5. This side now equals 0. So if you need to draw a line through your equal sign, do that. This stays 3x squared minus 13x, and this is minus 10. Now this looks very similar to what we just had in example 3. Okay? So when we go through there, we're going to go and factor this. So we have 3x and x. That's the only way to get 3x squared. Negative 10 is plus and minus, and this is 1 and 10. So if we take a look at that, I need to get 13. Well, if I do 3 times 10, this could also be 2 and 5. If I do 3 times 10, that's really too large. But if I do 10 times 1, that gives me a 10x, and this gives me a negative 3x. So we take a look at that. I don't quite have what I need there, so I'm going to have to switch those. Well, like we said, if I do 1 and 10, that's really too large. So we know that the 110 option doesn't work there. So let's take a look at 2, 5. So I'm going to need to put in a 2 and a 5. So I have 2x, I have negative 15x, and there's the negative 13x that I need. So I found the correct factors. They equal 0. And so now what I need to do is take that a times b and set those equal to 0. So I have 3x plus 2 is equal to 0. Or x minus 5 could equal 0. This one's pretty easy to solve, so we're going to add 5 to each side. We get x is equal to 5. Here we're going to subtract 2 from each side, and then divide by 3. So sometimes we only have fractions for one of our two solutions, and the other one is an integer. All right, ladies and gentlemen, I just realized that there is a little bit of a typo, so I actually need to go back and do the real number 4. I'm going to guess that some experience taught me that this example needed to be on there. So I'm going to take a look at the real example 4, so hopefully you were able to find the last one we just did and put it under example 5. But when we look at this, it's 2 terms. But what we want to look for are greatest common factors. So that's always what we want to look for. We haven't had many examples with that. But if I look here, 5 divides into 25 and 5. And then each of these has an a term. So 5a is going to be part of our greatest common factor. 5 divided by 5 is 1. And you have 2 a's factoring out 1a. And that leaves you with just a. Minus 25 divided by 5 is 5. You have 1a, you take it out. And it just leaves you with 5. This is still equal to 0. So you have your a times your b. So you have 5a is equal to 0. That's your a equaling 0. Or your b equaling 0, which is a minus 5 equals 0. Here you divide by 5. Hopefully you guys realize that a is still just 0. Or you're going to add 5 to each side, and you get a is equal to 5. So what we're doing here is really focusing in again on that factoring and seeing how we can use those to set our factors equal to 0, and then find solution. So hopefully that didn't confuse you there, ladies and gentlemen, and have a good evening.